Welcome to this Wood Solution presentation on timber design for durability. This presentation provides an overview of successful design approaches. The key steps in designing a durable timber solution are: first, assess the hazards that the timber will face in service. Then, match the timber and the connections with the expected hazard for the required service life. The next step is to detail the timber and the fixings to minimise the hazards. And lastly, we need to maintain the timber assembly regularly. Let's look at each of these steps individually. Step 1 is to assess the hazards that the timber will face in service. Hazard classes for applications have been established on a scale from 1 to 6, with hazard class 1 being the least hazardous to hazard class 6 being the most hazardous. This table links the hazard class with the exposure the timber is likely to face in an application. It notes the service life conditions and lists its probable biological hazard. The situation on the site also impacts the hazard level. Timber used outside above ground is in hazard class 3. However, this map shows the likely intensity of this hazard class in different zones of Australia, where Zone D is the most hazardous and Zone A is the least. Step 2 is to match the durability of the timber and its connections with the expected hazard for the required service life. Factors that need to be considered are firstly the natural durability of the species heartwood, then it's the treatment of the sapwood, and finally the selection of durable fixings. This table provides guidance on the probable service life of timber from a particular durability class for varying degrees of hazard. Remember that these only apply to the heartwood of the species. This table shows the direct connection between the treatment class applied to a timber and the expected hazard class experienced in an application. Step 3 is to detail the timber and fixings to minimise hazards. The two big considerations in this are moisture control and termites. Detailing for moisture should aim to keep the timber as dry as possible for as much of the time as possible. This minimises the chances of decay establishing. Detailing for termites really comes down to keeping the termites away from edible timber, by exclusion of the insects or by treatment of the wood. Lastly, step 4 is to inspect and maintain the timber, its finishes, its flashings, and any protective treatment. This can range from recoating a surface to replenishing a preservative system. So, in summary, successful design and specification for durability requires identification of the hazards to the timber in the application, correct timber and connector specification, giving the required service life and likely hazards, and design and maintenance of components so hazards are reduced or eliminated. For further information on durability design, download Wood Solutions Design Guide 5, Timber Service Life Design, from the Wood Solutions website.